Okay, today we are going to look at the second one, pointer registers, and if there is time, we'll look at index registers as well. And then we'll try to see if we can program the first assignment. Pointer registers. Now, another kind of pointer register is the base pointer. The first one we looked at is the stack pointer. Now we're looking at the base pointer. Now, the address in the stack segment register is combined with the offset in the base pointer to get the location of the parameter. To treat a register as a pointer, you need to put square brackets around it. So yeah. So if you look at MOV or move RAX RBX, it loads the value in the RBX register into the RAX register. So this is one point. But look at the one here. This one, it loads the value. It loads the value that is the RBX register is pointing to into the RAX register. Right. So the next register is index register. So in 32-bit, the registers ESI and EDI, and there are 16-bit rightmost portions, which is the SI and DI. If you look at the chart, following with the nomenclature, they are used for index addressing. Okay, and sometimes they are used in addition and subtraction. All right, so there are two sets of index registers or index pointer registers. That is the source index and then the destination index. Now, the source is used as a it's used as a source index for string operations, and then the destination is used as an index for, also used as a destination index for string operations. We said that there are three types of registers. We have what? General what? And then control and what? Yes. So now we are on the second one. We are done with the general registers. And in the general registers, we looked at other types of the subtypes of general registers like the base, like the pointer register, index registers, and so on. Okay, and even, for example, if you take pointer registers, you see there are also types of pointer registers. Okay, so you should know all of that. Okay. Now, the 32-bit and 64-bit instruction pointer register, and then the 32-bit and 64-bit flags register, they combine and they form what we call the control registers. When you are doing these things, when you are doing comparison, when you are doing jumping, okay, in assembly, that's how we call it, jumping. Okay, so you compare two registers and you say that, for example, if they are equal, then you should jump to blah, blah, blah. You should jump to a label. You will jump to a particular label or a particular procedure. Okay, so we'll see an example of that. So for example, JE is jump if they are equal to. Okay, so when you compare these two and you say, okay, if they are equal, JE print, where print is a label or a subroutine, and then you have a bunch of codes under print already. Okay, so once you do that, you are in some way, I would say, sort of playing with the flags. Okay, there are different types of flags in assembly. So you either put the flag on or you put it off. Is that okay? Now, putting it on and off has got values, sometimes 0 and then 1. Okay. All right. So the conditional instructions, they test the value of these flags to take control of the flow of other applications. So we'll see the different types of flags that we have. Okay. So the first one is the CF, which is the carry flag. And then you have parity flag, and it goes on and on. Like there are a lot of them. Okay. So flags only hold one bit that is either true or false. Now, like I said, 0 or 1. Okay. And you have flags being part of a kind of register. Okay, so what did we say control registers are? It's a combination of flags and what? And what? Instruction pointers. Okay. So in a subsequent slide, you're going to see definitions of each flag and what gets them to set to 1 or get them to set to 0. Do you guys follow what I'm saying? Okay, so there are many. We may not be running through all of them. Okay, but just know that a flag has either 1 bit, that is either 0 or 1, and depends on the particular computation you are doing, it sets to either 0 or 1. Is that okay? So maybe you can have the time to read through this. But as we perform some of these simulations or examples, then we can tell you, or we even show a table that shows when a value tends to 0 or 1. Or otherwise, you can follow the definitions. Okay. So carry flag, sign flag, 0 flag, auxiliary, and then parity, and so on. Okay. Yeah. So that leads us into jumps. So if you have a written program and you want to actually move from one place to the other, use the jump. Okay, so jump can be used to jump to, in fact, the different parts of your program. And it's based on labels. Okay, right. So if you look at this example, jump, start. Who can tell me, okay, maybe by the RTA it's very easy to answer, but who can tell me what actually happens if you just have this assembly line written in your maybe in your nano. You just write, you declare your global underscore start, and then you say start, then you say jump underscore start. What happens? Yes. Infinite loop, yes. So that's the answer. So it will just go and go. Why? Because we are jumping to the same start. Okay, so you just jump start to, so the passing of execution will be like x plus 1, x plus 1, x plus 1. So it's just like that. Okay, no result will be given. Okay. So when you are comparing, for example, it allows you to take different parts based on certain conditions. So we have different comparison statements. Later we'll look at them. You can compare register with a register, and you can compare register with a value. All right. So look at only these two conditions. So you see the example, for example, compare RAX and 23. What it means is that we are comparing a register with a value. Do you follow, guys? Okay, and then the next step is what? Comparing two registers. Now, after comparison is made, the next code that we often write is a jump statement. Okay, when you compare two things, the next line you write is a jump statement. Why? Because after the comparison, there is going to be a result, and then the result must be interpreted to move to some other part of the program. So, two types of jumps, conditional and unconditional. And then we said that each of them will set a flag to either be on or off. Okay, so let's look at this table. You can equally find this table online. Like, it's pretty easy to get it. Because this is not an exhaustive list. The jump symbol against its unsigned corresponding value and what happens after comparison. Okay, so for example, if you do JE means that you want to say jump if they are equal to. Okay, and you're comparing A equal to B. So the carry flag will be set to on if the comparison is true, and then will be off which is 0 if the comparison is false. Do you guys follow? Okay, so that's basically it. All right. So J and E is jump if not equal to, jump if greater than, and then the symbols are just writing. Jump is not equal to, and so on. Okay. All right. So if you look at this code, it says that compare REX to 23 is what? Register to value. Is that not so? Okay. And jump to the label do this. That is to say, if they are equal, if REX and 23 are equal, then it should move to do this label. So do this would be a label that you call, and under this label there is a bunch of codes, you know. Okay. And register to register, compare REX, RBX, jump if it is greater to do this. So I asked you to write a simple comparison code, which was, which some of you did. I mean, there's a gentleman here who did it very nicely. He sent me the pictures of that. There was some limitation, all right, but I felt it was a very good start for him. He did well. So maybe you can look at the samples I gave you. You can try. And you may encounter some challenges, but you're a champion if you fix them, I think. So let's look at that. How many labels do you see in this code? How many labels? There are what? 3. Comparison. Now, what is num1? Okay, if you see num1 here, what is num1? Anybody to tell me what kind of, yes? Is a pointer also. Num1 is not actually a value. Is also, it is pointing to some value. Now, this is a program we are writing that should take in values, okay, and then do comparison. So this is a very beautiful usage of pointers. So the thing is that I want to have a register as a pointer register. It should point to some value that will eventually be entered. Are you guys following? Okay, so that's one of the usage of this kind of register. So it's supposed to take num1 and then compare ECX with num2. So what's happening here is that you're moving. Which one is the source now? Source is what? Num1, right? So you're moving num1 to ECX, and then you're doing a comparison with num2. So that means the value that is going to be stored in ECX is now going to be compared with num2, that's in the second number. Okay. And then you're going to jump if the comparison shows that the value in num2 is greater than the value in ECX. Okay. Then it jumps to where? Check there. And this check there is actually a label, and you have a bunch of clues on that check there, right? Then in the end, you are supposed to write the largest number is blah, blah, blah. Okay. Now, look at this one. Section.bss or segment.bss. This is a place to reserve bytes. Okay, it's fine. And you see it's what? Large RESB2. So what it means is that large is the name or the label, okay, of the space you are reserving. Okay, so the bytes you are reserving, the space you are reserving is large. That's the variable name you've given to it. And then you're using the keyword reserve bytes, that is RESB. Okay, so how many bytes should be reserved for you in the variable large? It's just 2. Okay, so it means you are reserving 2 bytes. Usually you are using this when you want to get inputs. Okay, so that means that if anybody would enter some bytes that exceeds the allocated bytes, you get an error or you get a truncated result. So calls and jumps are essentially the same. However, when call is used, the original position of the call that was made will be returned to using the RET, which is the return. Okay. Now, call, the reason I'm saying is the same as jump is because it also helps you to move to other parts of the program. Okay. Yeah. We're going to try to modify the hello world code. Okay, please, let's move on. So I'm going to look for the hello world file. So this is how we left it the other time. And then it was running successfully. Now, our goal is to let this accept an input. So what we want to do is that, for example, if we, let me get some here. We want to say that if we ask a question like, what's your name? Or how old are you? Something like that. How old are you? Then someone should see it and then respond to us. Then maybe you say, hello, I am. So let's look at what we may need in this program, which is very important, okay? So it means that we will need to be able to use syswrite to ask the question, yes or no? Okay. And then how do you read? We may need sysread, right? To read the answer. And then we may need another syswrite to display, right? What? Yeah, forgive the typo there. Okay, so now you think about this, and then you can have your own variables that you want to use. So if you want to write this, you can use subroutines, okay, or you can use calls to do that. Okay, so let's get back. So we have section.text, fine, working so fine, but we want to be able to add, okay, maybe I'll just do, again, hello. Maybe, okay. So we want to be able to do a section.data here. And then under the section.data first, we need to get the first text, okay? So you can go like, maybe that is the question. So you say text Q, okay? Which is the question. And then you want to give it a defined byte. Okay, so DB. And then what's the question we're asking, guys? How old are you? Okay. All right. The next one, we need to define another text. Is that not so? So text, maybe we say text response, because we want to add this to the response. Okay, so we say, hello, I am blah, 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 right? So we want to have this as DB and then hello, comma. Okay, so something should come and fill in there. Okay, now the next thing we want to do is to reserve bytes. We want to reserve space for the input that is coming over. So what are we going to do? What do we declare, guys? Is what section or what? BSS. Okay, we're going to declare section.bss. So sorry about that. Section.bss. Okay. Now, the next thing is to tell the name of this BSS, what we are going to hold actually. So here we go. It's supposed to hold sorry, the year, okay, or age, maybe. The age of the person, and then we say RASB, and how many bytes should we reserve for that? Just want them to look in a line. Okay, so next we are going to now see the code. So first thing is we go to start, and then we're going to declare all the calls. Okay, whatever, all the calls that we want to use. So here, have to take away. So underscore start, and then what we want to do first is to call, and then what are we calling? We said the first one, we need to print the question. So give it a name. So you can call it print text Q, right? So maybe I'll make it like capital T. Okay. Are you guys following? So we go to the next call. I want to use this call to get name. Sorry, to get the age. Okay. So call underscore get age. That's the input that comes in. And then call underscore. And then the last call we are going to do is to print the results. Okay. So call underscore print, or if you like, display. Maybe something like that. Okay. Now that we have finished our calls, because we'll do return and it will come back to here, we need to exit. Okay. So can you guys tell me how to exit in 64-bit? Yes. It's a syscall for exit. Yes. Want to go? MOV RAX. What's the value? 60. And then we come down. We say what? MOV RDI. Is that also? Good. You are following. So MOV RDI. And then what's the value? 0. Thank you. Okay. Then what's the last thing we do? Syscall. Okay. Nice. So now that we are done, you see how the flow goes. So we come and do underscore. What's the first thing we are talking about? Print text Q. Is that also? And then we do our full colon. And then now we come and write. We come and write all the codes, the bunch of codes for that will help us to display. Okay, so this is going to be technically a syscall to display text Q. Is that also? So let's do the syscall. Are you guys with me? So what's the codes for syscall? One to go. MOV RAX, comma, value is what? 1. And then, sorry, MOV, what is the next register? RDI. And what's the value? 1. And then now we're going to take the variable that is holding the defined byte. Okay, so what is that register we are using? MOV what? RSI. And then comma text what? Q. All right, so that's it. Very simple. Okay. Then what's the next line? MOV what? RDX, our sum. So then this is going to tell us how many bytes of the defined bytes we have. So we have to literally go and count how old are you. Okay, so we count like 1, 2, 3, 3 letters, 3 bytes. So 3 bytes, and then you count the space, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, question mark plus, and then so on. So we have kind of 16 text, right? Okay, right or wrong? 16, right? 16 character space or character, whatever. Yeah, so we go on. So if our counting was wrong, our syswrite won't work. Okay, so guys, we should be careful about that. Right, so now, what do we add on syscall? So we add syscall. Okay, and then because it is a subroutine, we need to add on RET, return, right? Okay, so we do the same for all the labels. We do the same for all the labels. So let's first deal with everything that is an output, okay? Then we now come and do an input. So the next output label is what? Print, sorry, yes, print text R, is that also? Okay, cool. So let's give some space and make it nice. Okay. All right, so we do a full colon and then now we write our codes. Okay, so the same process, call them out now, move RAX, comma 1, and then move RDI, sorry, comma 1, move RSI, comma. And what do we put here? Text what? Text R, right? Okay. And how many bytes for text R? We just wrote hello and a space. Is that okay? So hello, HELLO space 1 5, right? Okay. So you can sometimes even declare it so that it's more than that. It's okay. But if it's lesser than that, it doesn't work. Okay. So here we go. So we can do MOV, RDX, and then we are going with 6 or 7, any of them. 7, okay, it's fine. Okay, and then syscall. And then return, right? Okay, nice. Okay, so the last one. The last one is for us to print every answer that is read. Okay, yes. And then, so here we go. So we're going to do underscore print, and that's a display, right? Okay, and then we do the same, x, comma 1, and then MOV, RDI, comma 1, and then MOV, RSI. What are we putting here? Okay, and how many bytes are we expecting from the person? We said how many? We declared how many bytes? We reserved how many? 18, right? So is that byte that you put here? Okay, so that's it. So you go MOV, and then it's RDX register, right? So 18. Okay, so then we do syscall and then return. So now we are left to the last subroutine. Okay. Now we are going to use a different syscall. It's not write this time. It's what? It's read also. So you remember the ID value and everything. Huh? Okay, so underscore get age. So we are going to, so now let's do it together, guys. MOV what? RAX, but it is 0. You know that? Output is 1. Input is what? 0. It's easy. Okay, so then you go, yeah. So are you guys following? Any questions here now? No? And then what do we put here? Yes, anybody smart here? What we put here? Come on, age. Yeah, this guy is following. Awesome. Sharp, or a sharp guy. Okay, so, and then bytes. How many bytes? Move RS, sorry, RDX, and then it's 18. Okay. And then what do? We do syscall. So it's quite long, I think. And awesome. So it looks like now we've ended. Any questions? Yes. So first I need to save it, Control O, and I've already saved it as hello.asm. Okay. Okay. All right. So NASM -F ELF 64. So we link to the object. Okay. So dot is a dot. How old hours are you? And then we said we can write like maybe 9, right? We said 9. Okay. Then it adds, hello, I am 9. Do you see that, guys? Okay, so that is it. So that's how to take input. Now you can do this for anything with a comparison as well. If you're following our comparison code, you can use subroutines and it works fine.